Hi students, welcome to the section on conducting polymers. Polymers that we see in our daily life are generally insulators. But there are certain polymers which possess remarkable ability to conduct electric current. And a polymer which can conduct electricity is termed as conducting polymer. In the year 2000, the Nobel Prize in Chemistry was awarded to Professors Alan J. Heeger, Alan J. McDiarmid, and Hideki Shirakawa for the discovery and development of electrically conductive polymers. Hideki Shirakawa found out the conducting power of polyacetylene, and this has led to the launching of new field of conducting polymers. Here are some examples of conducting polymers: polyacetylene, polyphenylene, polypyrrole, polythiophene, polyphenylene sulfide, polyaniline. You have to study all the structures of these compounds. If we look carefully, we can see that all the conducting polymers are having alternate single and double bond. That is, they are forming a conjugated system of diene. Now let's see how the conducting polymers are classified. Conducting polymers are classified mainly into intrinsically conducting polymers ICP and number 2 extrinsically conducting polymers. From the word itself, intrinsic, which means the conduction property of the polymer is due to some factor that is inside the polymer. And what is that factor? It is the presence of conjugated double bonds across the polymer backbone chain. And this extensive conjugation will result in the delocalization of the pi electron, and that is responsible for conductance. Here you can see the example of polyacetylene. There is alternate single and double bonds, and due to the conjugation, these pi electrons are free to move along the backbone of the polymer, and this will cause conductance. What is extrinsically conducting polymer? ECP. Here, the conductivity of the polymers is due to the presence of externally added ingredients in them. Now we will move on to the classification of intrinsically conducting polymers. They are again classified into conducting polymers with conjugated pi electrons and doped conducting polymers. In conjugated polymers with pi electrons, we know that there is extensive conjugation along the polymer backbone, and the overlapping of conjugated pi electrons over the entire backbone of the polymer result in the formation of valence band and conduction band. And the electrical conduction occurs when electrons from valence band are excited to conduction band either thermally or photolytically. Polyacetylene, polyaniline are all examples of this type of polymers. And what is doped conducting polymers? Doping, as the term itself, we know that it is addition of some impurity from outside. Conductivity of conducting polymers can be increased by creating positive and negative charge on the polymer backbone either by oxidation or reduction, and this process is called doping. The conjugated pi electrons can be easily oxidized or reduced. Why? Because they have low ionization potential and high electron affinities. Doping are of two types: p-doping and n-doping. Let's compare the between two. In p-doping, some of the electrons from the pi bond of the conjugated polymer are removed by oxidation with Lewis acid like ferric chloride. And we know that Lewis acid, what is a Lewis acid? It is a substance which accepts electron. So if we are adding Lewis acid to the polymer, this Lewis acid will take away one of the electron of the pi bond of the conjugated system, and that will result in the formation of a cation. See, this is polyacetylene. We can represent that CHX. And if we are adding Lewis acid like ferric chloride, this ferric chloride removes one of the electron of the double bond of the polyacetylene system, and that will result in the formation of CH positive. And the radical cation so produced is called a polaron. Here what happened? Oxidation of the polymer has taken place. What is oxidation? It is the removal of electrons. So this Lewis acid has removed electrons from the polymer, and such such process called oxidative coupling. Now let's see what is N-doping. In N-doping, some electrons are introduced into the polymer by reduction with Lewis bases like sodium naphthalide, and this will lead to the formation of an anion. Here the Lewis base. What is a Lewis base? It is a electron donor. So this Lewis base will give electrons to the polymer, and now the polymer is having excess electron, or the polymer we are adding electrons, and that has resulted in the reduction of the polymer. And so now due to the presence of excess electrons in the polymer chain, it will conduct electricity. Take for example polyacetylene. Into polyacetylene we are adding sodium naphthalide, which is a Lewis base and is having excess electron. And this sodium naphthalide is giving excess electron to polyacetylene, and now it has changed to N-dot polyacetylene having excess electrons plus naphthalene. So in P-doping, the conduction is due to positively charged cation. We know that when cation is formed at one point of the conjugated system, the pi electrons of the nearby conjugate bond will move to that position, and hence the position of the positive cation is moved along the chain. So here we can consider it as a hole, and due to the movement of holes, conduction takes place. In N-doping, the Lewis base is giving its electrons, and due to the presence of excess electrons in the polymer chain, conduction takes place. Now let's move on to the classification of extrinsically conducting polymers. We know that conducting polymers are mainly classified into intrinsic and extrinsic. And extrinsically conducting polymers are again classified into conductive element filled polymers and blended conducting polymers. We have discussed what is extrinsically conducting polymers. I hope you remember. In extrinsically conducting polymers, the conduction is due to the presence of externally added ingredients in them. So depending upon the type of the ingredient that we have adding, it is again classified into conductive and blended. In conductive element filled polymers, we are adding some conducting elements such as carbon black, metallic fibers, metal oxides, etc. Here the polymer is just acting as a binder to hold the conducting elements together. So we know that if we are adding some conducting elements to the polymer, due to the presence of the conducting element that is present in the polymer, the conductivity of the polymer is increased or enhanced. But sometimes the addition of these fillers reduces the tensile strength and impairs strength of the polymer. Take for example, if we are mixing carbon black into polypyrrole, we are getting a conductive element filled polymer. And this polymer is used for electromagnetic shielding. Some of the properties of conductive element filled polymers are: it is low in cost, light in weight, mechanically durable and strong polymers can be obtained, and it is easy to process in different forms, shapes and sizes. In blended conducting polymers, polymers are obtained by blending a conventional non-conducting polymer with a conducting polymer. As you all know, blending is the mixing of two polymers, of which one is non-conducting and other is conducting. By this method, we can convert an insulator type polymer into a conducting polymer. For example, if we mix polystyrene, which is a conventional non-conducting polymer, With conducting polymers such as polyacetylene, polypyrrole, polythiophene, which are all conducting, we get a conducting polymer with enhanced conducting properties. That's all about the classification of conducting polymers. Thank you.